what it would take to get a 4 on an FRQ like number 10 on your review. This is from a past AP test. It was the 2005 test. So you could Google search this and see the exact rubric. But I wanted to talk us through the parts, especially because there's no breakdown here of what you should do A, B, C, and D. This question, if you've read it, it says is provide statistical evidence to support your answer on whether or not you should believe the company's claim that there are vouchers or prizes in 20% of their cereal boxes. So if I'm going to provide statistical evidence, I need to run through a significance test for proportions. So that's exactly what I'm going to do here. So the first thing we have to state. We're going to do our state, then make a plan. We're going to do our calculations, and then we're going to run through our conclusion based on those calculations. So the first thing, define your proportion. Nothing in the problem prompts you to do any of this. You have to know how to go through the steps of a significance test. So I define my parameter. What's the proportion I'm examining? The proportion of boxes of this breakfast cereal that include a voucher for a free video rental. This is the parameter. Then from there, I take the claim made by the company. Remember, null hypothesis means there's no change. So the claim the company is saying is that the proportion of winning boxes with these vouchers is 20%. The alternate hypothesis is P is less than 20%. That's what the students believe, that there aren't actually 20% of the boxes that prize. Once we have our state, we make our plan. I'm going to want to do a one proportion Z test. Well, in order to use Z's, there's some things I have to check. Is my sample large enough? Is it independent? So first I check for large enough. N times P. Remember, if you have P, use P. Do not use P hat. If you have P, use P. So I take my sample size, which is 5, times 0.2, and I get 13. That's greater than 10. The complement to that is also greater than 10. The problem tells us to assume the sample is random. We also assume that 65 is less than 10 for all boxes of this type of cereal. That is a very safe assumption that the company is making more than 650 boxes. So with conditions met, I will conduct a one sample Z test at a significance level of 5%. We were not given a significance level. You really should state that level before you start the problem, before you run your test. It needs to be stated somewhere. Okay, so then the next thing I'm going to have to do is the calculations. I need my test statistic. Remember, this is all that's on your formula sheet. Your test statistic is statistic minus parameter divided by the standard deviation of the statistic. So if I'm running this calculation, and I've just said I'm going to do a one proportion Z test, okay, then I know my test statistic is a Z. I'm going to be working a curve centered around 0, standard deviation of 1. My statistic is the P hat. If you look back in the problem, P hat, from their sample, they have 11 with vouchers out of 65. So that's a P hat of about 0.169. So I'm going to take my P hat, subtract off the population parameter, which was the null hypothesis claim. Remember, our null hypothesis claim was 20%. Then I have to divide by the deviation of the statistic. Now this is also on your formula sheet. If you go to proportions, a one sample proportion, it is going to give you the formula for sigma, or P hats. It's going to be the square root of P times 1 minus P, all divided by N. We have a claim that P is 20%. If you have P, use P. So when I put in my standard deviation formula, I'm going to have 0.2 times 1 minus 0.2, which is 0.8, all divided by our sample size of 65. put this into my calculator. If you put it all into your calculator at once, make sure you put parentheses around your numerator and around denominator. We get a test statistic of negative 0.62. That means our sample is just 0.62 standard deviations below the mean, as that is not that far below the mean. That is our test statistic. If you know anything about our critical values, a critical value of 5%, if our alpha level we set was at 5%, our Z star is going to be down here at negative 1.645. This will be our critical value. Already, if I compare these things, I know that I do not have any significant evidence to reject the null hypothesis. But I still want to go through and find the p-value. Remember, I have to find the probability of getting this test statistic. So the probability that Z is less than negative 0.62, I can use a table at this point, or I can use my calculator, normal CDF. It's going to be 0.2676. If you're not sure how I got that, we can go into our calculator. We go into second vars, our distributions. This is a normal distribution. We're working with z-scores. Lower bound is negative infinity. My upper bound is my test statistic, negative 0.62. The mean is 0. The standard deviation is 1. We're on a normal curve, a standardized normal curve. And that's how I get a p-value. The area left of my test statistic is about 26.76%. There is a 26.76% chance of obtaining this test statistic, this original p-hat. There is a 26.76% chance that we would a sample of 11 successes out of 65 boxes of cereal. Okay, so what's our conclusion? What can we do from there? We've done all the calculations. From here, we just say, since the p-value, 26.76%, is larger than the alpha that I set, or actually really any reasonable alpha you might set, even if you chose 10%, we cannot reject the company's claim. We do not have statistically significant evidence to support belief that the proportion of vouchers is less than 20%. All of these steps is really what you need in order to get a 4 on the P test on this type of question.